Hello Jyotsna. In our previous lesson, we discussed three major results: the sum of the first n natural numbers, some of their squares and some of their cubes. Let's see if you remember those results.
Yes, ma'am, I do remember them. The sum of first n natural numbers can be given by n into n plus 1 whole upon 2. And the sum of squares of first n natural numbers can be given by n into n plus 1 into 2n plus 1 whole upon 6.
That's right.
And the sum of the cubes of first n natural numbers, ma'am, it can be given by n into n plus 1 upon 2 whole square.
That's right. And if you remember, we also discussed how to find the sum of n terms of a given series when its nth term is known. If you remember, we also discussed the possibility of given the nth term and therefore using this idea that sum of the n terms is actually nothing but sigma of tk, where k varies from 1 to n.
Yes, ma'am.
Today we are going to discuss the application of these major results in finding sum of n terms of certain very special series. Let's take a look at few of them. Here you are asked to find sum to n terms and the series are given in the form of 1 into 3 plus 3 into 4 plus 5 into 5 and so on. And others are also almost same as in factors, but you can have independent just single terms as 1 cube plus 4 cube plus 7 cube.
Yes, ma'am.
I am sure you will agree with me that they are special since they are neither arithmetic nor geometric progressions. But at the same time, just with the one look, I am sure you will also be able to identify a certain pattern present among these terms. Let's see, Jyotsna, if you can identify what the next term in this series is.
Ma'am, the next term in this series is 7 into 6.
7 into 6, that's right. I think you must have guessed it by 1, 3, 5 will give you 7 as the next term here, and 3, 4, 5 automatically next should be 6. Similarly, you can identify the next terms here.
Definitely, ma'am, I can identify. It is 4 into 5 into 6.
That's right, 4, 5, 6.
And for the next one, it is 5 into 9 square.
Absolutely, it's 5 into 9 square because 2, 3, 4 gives us 5 as the first factor. 3 square, 5 square, 7 square. Automatically it should be 9 square. Here 1 cube plus 4 cube plus 7 cube.
It gives out 10 cube, the next term.
That's what the next term looks like. And now, since you have been able to identify the next term, understanding the pattern, let's see if we can use your observation and find the nth term of these series. Let's start with the first one.
Yes,
we have the series as 1 into 3 plus 3 into 4 plus 5 into 5 and so on. As you could see, the terms are coming from two arithmetic progressions, one which has 1, 3, 5 and so on as its terms, and the second one is 3, 4 and 5. You gave me the next term as 7 into 6, knowing very well that 1, 3, 5 should be followed by 7. And here 3, 4, 5 should be followed by 6. What you can now understand is to find the next term you have multiplied these two, and therefore the nth term of this series will be nothing but the product of the n term of the first arithmetic progression with the nth term of the second arithmetic progression. Let's see if you remember how to find the nth term of the first series.
Yes, ma'am. Because for the nth term,
yes,
the formula is Tn is equal to a plus n minus 1 d.
That's right. So, we will use this result here, and so
for the first series, we can put it as 1
right
plus n minus 1
exactly
into 2.
2. That is our common difference in this series.
Yes, ma'am.
And therefore, it becomes
2n minus 1.
2n minus 1. Similarly, I am sure you will be able to try for this.
Yes, ma'am. Here it will be 3 plus n minus 1 into 1.
Right.
It comes out to be 2n,
n
n plus 1.
n plus 2. You can see
Oh.
n into 1 is n, 3 minus 1 will make it
n plus 2.
and therefore our nth term of the given series, which is going to play an important role in finding the sum to n terms, can be written as 2n minus 1 into n plus 2, and this can always be simplified to, opening the brackets, 2n square plus 4n minus n will make it plus 3n minus 2. And these are the questions which we discussed in our previous lesson also. Given nth term, we will be able to find the sum. And so, we can write Sn as sigma Tk, as I explained, is a way of representing the sum where k varies from 1 to n, or you can even write it directly as sigma Tn, where Tn is the nth term directly, knowing that as you take the summation, the variable will take the values from 1 to n. This now will be same as, for our example, sigma of 2k square plus 3k minus 2, as k varies from 1 to n. And as we discussed in our previous lesson, summation is distributive. So, it will go inside and we can rewrite it as sigma of twice of k square plus sigma 3k minus sigma of 2, where k varies from 1 to n in all the summation. Don't forget to write sigma of 2 also. Although there is no k appearing here, it does not mean that 2 is going to appear only once. Remember that. And therefore, now I am sure you can follow it up, Jyotsna.
Yes, ma'am.
What will be the next term?
The next term will be 2 sigma k square.
Right. So, we can always take 2 out. It's sigma of k square, and do you know its value?
Yes, ma'am. Since it is the sum of the first and natural square of the first and natural numbers,
That's right.
it will be written as n into n plus 1
Yes.
into 2n plus 1
That's right.
whole upon 6.
Exactly.
And for the next term, since it is the sum of the first and natural numbers,
And we can always take 3 out of the summation.
yes, ma'am.
So,
So it will be written as n
yes.
into n plus 1
That's right.
upon 2.
Upon 2. And this minus of sigma 2, as I mentioned a moment back, 2 is to be added as n, or the variable k changes the value from 1 to n. So, 2 will appear in the sum n times, and 2 added n times is nothing but 2n. So, you will subtract 2n from this whole expression. What is left is just simplification. You can cancel the common numbers, any factor that may be appearing, and combine these terms. The best way, as I can see right now, is you can take n common from the expression. So, let us work it out and see what it turns out to be. Your Sn will be equal to n out, and we are left with n plus 1 into 2n plus 1 by 3 plus 3 into n plus 1 by 2, since n has been taken out as a common number, and you have minus 2. Rewriting, this is same as n, and taking the LCM, it's 6. In the numerator, you will get twice of, opening the brackets, 2n square plus 3n plus 1 plus 9 into n plus 1, that is 9 of n plus 9 minus 6 into 2 is 12. And therefore, it will be all simplified to n times of, just have to go on simplifying as and where possible, 4n square plus 6n we get from here, and you have 9n, and that will make it same as 15n. 2 plus 9 is 11, 11 minus 12 will make it minus 1 by 6, and that can be easily taken as your final answer. So what we have done here is, starting with understanding the pattern present in the series, we learn how to find the nth term. Once you have got the nth term, it's almost a mechanical process of applying the sum of the first and natural numbers, sum of the squares, and if possible, sum of the cubes, as our next question will require. Let's take a look at our next question now.
Yes, ma'am.
We have find the sum to n terms. The series is 1 cube plus 4 cube plus 7 cube and so on. So before the nth term, I am sure, as you said earlier, you will be able to give me again what the next term is.
It will be 10 cube, ma'am.
That's right. So we know the next term. So we again have a feeling as to what the pattern is. But what will be the nth term here?
Ma'am, should we simplify the series to 164?
No, 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 no. We are not going to do that. It will not be of any help. If you have cubes or squares present in the series, just leave them as that, for the time being at least. What you have to understand is, it is the base series, because when you learned and recognize 147 changing next term to 10 or then 10 cube, it was 147 which was playing an important role. So it is the base series 147 which will identify what the nth term is, because the nth term of this will be the cube of the nth term of this arithmetic progression. And as you can see, 147 means we can again use Tn is equal to a plus n minus 1d. So what will be the nth term here? A is 1, n minus 1, and the common difference is 3. So it will be same as 3n minus 2. And therefore the nth term of our series, not to be mistaken with this result, nth term of our series will be the cube of 3n minus 2. And what you have to just do is apply a minus b whole cube, and you will have the nth term as, this will simplify to 9n cube minus 54n square plus 36n minus 8. And so using a minus b whole cube, we can write the term as 27n cube minus 54n square plus 36n minus 8. And so as you can see, the only difference in this and the previous question is, here we have a cubic expression. But we can still go ahead and say sum of the n terms is sigma tk, where k varies from 1 to n, and therefore it is same as sigma of 27 k cube minus 54 k square plus 36 k minus 8, as k varies from 1 to n, which I am sure you can again write as 27 sigma k cube, k varies from 1 to n, minus 54 sigma k square, as k varies from 1 to n, plus 36 sigma k, where k varies from 1 to n, and you may even write this 8 directly to be same as minus 8n, because 8 on being added n times is again going to be 8n. Now what you have to do is replace sigma k cube by the result sum of the cubes, and therefore it is going to be n into n plus 1 by 2 whole square, and the same can be done for the other two terms. Now what you have to do is substitute the values and simplify. I will leave that for you. Let us move on to another question. So Jyotsna, let us concentrate on our next question, which says find the sum to n terms. The series is 1 into 3 square plus 2 into 5 square plus 3 into 7 square. Again what you have to do is identify the nth term, which as you can see is going to be the product of the two series or the nth term of the two series that are used here. Let's start with the first one. What will be the nth term of the first factor series, that is 1, 2, 3?
It will remain n only.
It is n only, as simple as that. Whereas for 3 square, 5 square, 7 square, as I have suggested in our previous question, what you have to do is identify the nth term of 3, 5, 7, which is clearly a plus n minus 1 d, that is 2 here, which is same as 2n plus 1. And so the nth term of the given series will be same as n into 2n plus 1, but with a whole square now on it. As you have 3 square, 5 square, 7 square, the nth term of the given series will actually be the n into the nth term of 3, 5, 7, which is 2n plus 1 and a whole square, which as you can see can be easily simplified. It's same as n into 4n square plus 4n plus 1, and therefore it is same as writing 4n cube plus 4n square plus n. A rather simple expression, but it is again cubic, and so you will have to use the sum of the cubes of the first n natural numbers. And so repeating the process again, Sn will be equal to sigma of, let me take the question now directly as sigma of Tn, because this is a universally accepted form. Therefore, you can and you should rather get used to using summation as sigma Tn. So, you can avoid yourself writing everything in k and then translating it in terms of n. Let's see if you can figure it out. Sigma of Tn, which is same as with an understanding that this is a sum of the n terms, and therefore it is going to be same as sigma of 4n cube plus 4n square plus n, and that can be directly written as sigma is distributive, as we have done in our previous questions, sigma of n cube plus 4 sigma of n square plus sigma of n, and therefore we can go ahead and say sigma n cube being the sum of cubes of the first n natural numbers will have the value as?
It will have the value as n
Right.
into n plus 1
Right.
upon 2 whole square.
Exactly. And this will be same as 4 into
It will come out as n into
n plus 1.
into 2n plus 1 whole upon 6.
That's right. It's the sum of the squares of the first n natural numbers. Sigma n is the sum of the first n natural numbers, and therefore we can write it directly as
It will be written as n into n plus 1 upon 2.
upon 2. And this again should be simplified,
Yes,
and
ma'am.
for that, as you can see, this n plus 1 is a common factor. So, I can take n into n plus 1 out and can rewrite the whole thing as Sn will be equal to, and in the first term of course that 4 is getting cancelled. So, I am left with n into n plus 1 out, and inside we are left with n into n plus 1 plus 4 by 6 will reduce to 2 by 3, and n plus 1 gone, you are left with 2n plus 1 plus 1 by 2, and that just needs to be simplified again, n into n plus 1, and you can take the LCM to be 6, and you will have 6n square plus 6n plus 2 into 2 will make it 4 times of 2n plus 1 plus 3, and therefore it will all simplify down to n into n plus 1 into, as you can open up, 6n square plus 8n and 6n will make it 14n, and 4 plus 3 is going to make it 7 by 6. and that is what your final answer looks like. Do make an effort to simplify as much as possible and factorize if it's possible. Otherwise, you can leave it as what we have done right now. And that is one of the applications, but it is, as you could see, almost repeated process as in our previous cases. Next question looks very special. Let's see if you can figure it out. The question says, Jyotsna, sum to n terms again, but our series is 1 square by 1 plus 1 square plus 2 square whole divided by 1 plus 2 plus 1 square plus 2 square plus 3 square divided by 1 plus 2 plus 3 and so on. Try to see what the next term is going to be.
The next term will be 1 square plus 2 square plus 3 square
Right?
plus 4 square
Absolutely.
whole upon 1 plus 2 plus 3 plus 4.
That's right. And so what will be the nth term?
Nth term, ma'am, because there are two,
The numerator and denominator. So you have to write for the numerator and denominator separately. So as you can see, what you have done is written 1 square, 2 square, 3 square up to 4 square for the fourth term.
so ma'am, it is the square of first and natural numbers.
Okay. So
Again?
it can be written as 1 square plus 2 square plus up to
N square.
n square, because it's the nth term that we are writing. So it will stop at n square. It's going to be the sum of, here it is the sum of the squares of first 4 natural numbers. Now we have the sum of the first, or the squares of rather first n natural numbers, and it will be divided by,
It will be divided by the sum of the first n natural numbers. That will come out as 1 plus 2 till n.
that's right. Now do we know what the value of the numerator is? What is the sum of the squares of the
We
first n natural?
can put it in the formula, ma'am, again.
Yes. So we can rewrite the nth term using the sum of the squares of the first
First n
natural numbers as n into n plus 1.
into 2n plus 1 whole upon 6,
That's right.
and that whole again upon n into n plus 1 upon 2.
Upon 2. This is the sum of the squares of the first n natural numbers, and this is the sum of the first n natural numbers itself. So we have used the result in identifying the nth term only. We have yet to calculate the sum. So remind yourself, the question is not going to be over right now. This of course gets cancelled, n plus 1 and n, and this will be simplified to only 2n plus 1 by 3. Also, as I said, Sn can be written as sigma Tn. It can be written as therefore sigma of 2n plus 1 by 3. As we take out any constant out of the summation, even this by 3 will come out, and therefore it will be written as, the sum will be same as 1 by 3 times of. Take that 3 completely out, and it will be same as twice sigma n plus sigma of 1. Therefore, 1 by 3, as I suggested, sigma n is, remind yourself, a way to replace sigma k, where k varies from 1 to n, but it remains sum of first n natural numbers, and therefore it has the value known to us as n into n plus 1 by 2. Sigma 1 is 1 added n times, so it's clearly only n. Simply 2 gets cancelled, you are left with 1 by 3 into n square plus n plus n, so you get n square plus 2n by 3 as the sum of a series, which definitely looks quite threatening, but not anymore, I assure. Let's move on to one more question which will kind of wind up the lesson for today. What it gives us is a connection, a relation between the 3 major results that we have been using today and we discussed in our last lesson. Let's note down our question. It says, if S1, S2, S3 are the sums of the first n natural numbers, their squares and their cubes respectively, then prove that 9 times S2 square is equal to S3 into 1 plus 8 times S1. I hope you have got the question. Let's start with what we can use. We are given S1, S2, S3 as sum of n natural numbers and the cubes and their squares, sorry. So let's start with what is S1 equal to?
S1 will be equal to n into n plus 1 upon 2. And because S2 is square of the first n natural numbers,
It is the sum of the squares of the first n natural numbers.
It will be n into n plus 1 into 2n plus 1 whole upon 6.
That's right.
And since S3 is sum of the cubes of the first n natural numbers, it will be n into n plus 1 upon 2 whole square.
Absolutely. So we know these values. We have used it all through the question lesson right now. What you have to do is look at the expression that we want to prove. So start with 9 times S2 square. 9 times S2 square will be same as writing 9 into n plus 1 into 2n plus 1 by 6 whole square. And that you can see is going to simplify to 1 by 4 into n plus 1 into 2n plus 1 whole square. Only that 9 and 36 have been simplified. Let's start with the right hand side. Right hand side was S3 into 1 plus 8 times S1. And what you just have to do is write S3 as n into n plus 1 by 2 whole square, and 1 plus 8 times S1 will be replaced by 1 plus 8 into n plus 1 by 2, and that, as you can see, is going to get simplified here. This is your cancelling away, and therefore you will be left with n into n plus 1 whole square by 4, and in this bracket it's going to simplify to 1 plus 4n square plus 4n, which is clearly 2n plus 1 whole square, and therefore I can write the right hand side, that is S3 into 1 plus 8 S1 as n into n plus 1 into 2n plus 1 whole square divided by 4, which is exactly what we have simplified 9 times S2 square as, and therefore we have proved our relation. So what we have done today is only the simplifications based on the use of the sum of the squares first n natural numbers and some of the cubes, and of course the sum of the first n natural numbers itself. Knowing the results, the task became quite easy. In our next lesson, Jyotsna, we are going to consider certain more special series. We will just give you a glance at what they look like, as here you have the series as 1 plus 2x plus 3x square, and you can see they are factors, but 1, 2, 3 is an arithmetic progression, 1 into x square is not. It's a geometric progression, and therefore the series that we are going to discuss in our next lesson will be something to do with both arithmetic and geometric progressions. And so, Jyotsna, in our next lesson we will consider these special series. For now, let's wind up.
Thank you, ma'am.